Hi, I'm Wendy Crone. I'm a professor in the Department of Engineering Physics at the University of Wisconsin-Madison, and I'm a member of our Materials Research, Science, and Engineering Center. I'm also a big fan of puppets, and I'm going to introduce you today to 3 finger puppets that I've made and teach you how to make them too. Armchair Anya, Zig Zag Zane, and Chiral Carolina. You might notice that these puppets have a pattern on them. We're going to talk more about this pattern and how it gives Armchair Anya, Zig Zag Zane, and Chiral Carolina special abilities. You may have heard of the hexagon shape in math class. This is a really important shape that has 6 sides, and it appears in nature in a number of different ways. You've probably seen pictures of a honeycomb that bees make, for instance. The bees create these hexagons all stacked together in a tight way so that they can store their honey. Some chemical molecules also form hexagonal patterns, smaller than the eyes can see. Carbon atoms are everywhere in nature, in the air, in dirt, and even in you. These atoms can connect to each other in a variety of different ways, including the hexagonal pattern that we just talked about. If there are many carbon atom rings all attached together, then we get this pattern that looks like a honeycomb. When the hexagon connections represent carbon atoms, we call this graphene. Graphene sounds a little bit like graphite, which is what the inside of your pencil is made of. Graphite is a form of pure carbon. It contains many hexagonal pattern sheets all stacked on top of each other. When you write with a pencil on a piece of paper, you're leaving a trail of these graphene sheets on the page. These sheets of graphene can be rolled up to make what scientists call carbon nanotubes. They're rarely found in nature, but scientists and engineers have learned how to make carbon nanotubes, and they're using those carbon nanotubes to create new materials and new devices. I told you earlier that I like puppets, so let's use our artistic abilities to create some finger puppets. First, we want to draw out a graphene sheet. Each hexagon is connected to the other in the exact same way. We can make a stack of hexagons on top of each other, and then we can make the hexagon neighbors by connecting them out like that. And we can make our sheet as big as we want to make a big carbon nanotube puppet or a small one. Now we can take a closer look at the pattern of the hexagons. I'm going to use another color marker to highlight the zigzag pattern. So it's just going zigzag, zigzag, all the way across. And when I roll up this pattern to form a carbon nanotube, I'm going to connect those zigzags to each other to create the zigzag pattern of carbon nanotube. Now you can make it as skinny or as large as you like, but I created Zig Zag Zane here so that he can fit on my finger. And you'll see that Zig Zag Zane has this belt around his middle that's showing the zigzag pattern. This pattern is going to be a zigzag carbon nanotube. I'm going to put a Z up here at the top to remind me that it's zigzag, and I'm going to give him a little face so he has some personality. I can roll up Zig Zag Zane into a carbon nanotube finger puppet by curling up the sheet. I may want to trim the edges so that I can make him nice and tight to fit on my finger. Here's the Zig Zag Zane I finished earlier. He's just a model for something that's too small to see with our eyes, but he depicts the kind of carbon nanotube that's called zigzag. If I rotate the carbon nanotube sheet, I notice that there's a different pattern in this direction. It's not a zigzag anymore. And scientists call it an armchair pattern. So this armchair pattern that's going across here is going to help me make a different carbon nanotube. I'm going to put a fancy A up here at the top and give this little carbon nanotube some personality. I'll call her Armchair Anya. And Armchair Anya is going to have a belt of this armchair pattern around her when it's rolled up into a carbon nanotube. The last carbon nanotube we're going to make is in between the two. We're going to call this last one a chiral carbon nanotube. Chiral is a word that sounds a little bit like spiral and means that the hexagons are going to wrap in a spiral around the tube. So in between the armchair and the zigzag, I'm going to write a C up here to remind me that this is the chiral pattern. I'll give him a little face, Chiral Carolina, a little face too. And when we roll up this pattern, we're going to notice that our zigzag and our armchair spiral around the carbon nanotube. You can keep all of your finger puppets on one sheet and just roll them in different ways to see the different types of carbon nanotube patterns. Or you can make 3 different finger puppets and tape them together so that your finger puppets can talk to each other about their different properties.
Hi, Zane. What are you doing?
I'm lifting weights to get stronger.
Don't you know that you, me, and Carolina are already super strong materials?
Yeah?
Let's see if Carolina will help us demonstrate. Hey, Carolina, do you want to show Zane how strong you are?
Sure, I'm super strong. Each of you grab an end and pull.
Wow!
You are strong.
If you pull on us, we are super strong.
But when I'm lifting the little weight, I don't seem so strong.
Well, that's true. We bend easily.
What do you mean, Carolina?
Zane bends in half really easily. It's like the strip of paper. It's pretty strong when we pull on it, but it's also bendy and floppy.
Is that true for real carbon nanotubes too?
It sure is. Carbon nanotubes are long and skinny like a piece of hair, but even smaller. They're super strong when you pull on them, but they bend and buckle pretty easily.
That doesn't sound very useful.
Well, it sure is. Carbon nanotubes can be spun into special kind of yarns and fabrics that are super strong and lightweight. Scientists and engineers have used them on the Juno spacecraft that traveled all the way to Jupiter. The carbon nanotube sheets protected the delicate components against electrostatic discharge.
Electro sounds like a different kind of property. Do all of us have the same kind of electrical properties?
I've been told that I'm highly conductive. Electrons can run along the length of my body really fast to get to where they want to go.
Well, it all depends on our chirality, how spiral the pattern of our carbon atoms are arranged. We get different electrical properties because of this arrangement.
Well, that seems cool. Is it useful?
I heard that engineers are using carbon nanotubes to make new electrical devices using the different properties, now that they know how to make different types of carbon nanotubes. Because we're bendy and flexible, it means that researchers can make new computer devices that are flexible, like fabric.
Well, we're special in a lot of different ways. Carbon nanotubes are also the blackest black you'll find. We'll show you as we're waving goodbye.